Happy snow day again. This is crazy. This part I tried to do in the Google Meet, so feel free to skip it if you missed it. So like we learned up there, two shapes, similar figures are two shapes that are the same shape, but different sizes. And the symbol for similarity is a lot like the congruent sign, but it's got just the wavy line. And then the numerical relationship between the shapes is called the scale factor. In other places, you might see similarity ratio, but I will mostly use scale factor, okay? All right, so the first example that we're looking at is how to determine if shapes are similar or not. And so really what we have to do is we just have to compare the ratios of all three sides. So we're just gonna compare the three sides, compare ratios. So here's how I stay organized, guys, because people, like this one is pretty easy. We can tell that this 20 matches up with the 24, and we can tell that the 15 matches up with the 18. Sometimes you're going to get to shapes like this down here where they're kind of rotated or turned or flipped, that kind of thing. So here's how I stay organized, okay? I make a little chart for myself, and I say, okay, I'm going to put all the small numbers on top, the small triangle numbers, and I'm going to put all the big triangle numbers on bottom. And then what I like to do is I like to list the sides in order from smallest to largest. So in my small triangle, the smallest side is 15, the next biggest is 20, and then the next biggest is 25. And then for my big triangle, the smallest side is 18, the next biggest is 24, and the next biggest is 30. From there, I'm going to take each of these and I'm going to simplify those fractions. So 15 over 18, those are both divisible by 3. That's 5/6. Now, here's the cool thing. If you're not great at reducing fractions, never fear, your calculator is here. Okay, so if you want to do 15 divided by 18, great, it does it for you. If it doesn't show up automatically for you, there's a button right here, this FD button. Just hit that FD button until you see this F right here. That says that you're going to be in fraction mode instead of decimal mode. And then when you do it next, it'll give you the fraction, okay? If you're using a different calculator, again, if it gives you that decimal, there's a little button right down here that says change your number into a fraction, and it'll do that for you right away, okay? If you're using a different calculator other than these, just let me know. Maybe stop by my office hours if you're struggling. And then the next, I'm going to do the same thing for all of these. So because they're all the same, that means that my triangles are similar. So yes, they are similar. And it says, if they are similar, what's the scale factor? The scale factor is that right there, 5/6. So again, we're gonna do, I like to do small triangle on top, big triangle on bottom. I'm gonna list my sides in ascending order, so from smallest to biggest.
So for my small triangle right here, the smallest side is 15, then 25, then 30. And then for the big triangle, I've got 42, 70, and 84.
Let's pull out my handy dandy calculator. I got all 5/14, so yes.
They are similar. The 5/14 is the scale factor.
All right, so let's look at the next type of problem, which is where we're solving for a side. In this one, it's very similar to before, except now we know that the triangles are similar. And we need to find one of these lengths. So I'm going to start with the kind of the same setup as much as I can. I'm going to take that little triangle over big triangle. So I'm going to start with that. My medium side is 9 and then 10. So I'm guessing that this side is the smallest side. 30, 54, 60. Now here's the thing. We don't need all this information because what we're going to do is we're going to solve the proportion. So I'm going to take this one for sure, x over 30, and then whatever one I like. I personally like this one because they're nice numbers. If you wanted to choose 9 over 54, that's fine. So now I'm going to basically just solve this. So this is how I'm choosing to solve it, guys. I'm going to multiply both sides by 60 because that gets rid of the 60, and I'm going to multiply both sides by 30 because that gets rid of the 30. Now what's left is this 60 times x and 30 times 10. And then I just divide by 60 because I'm getting x alone. So x is 5. Scale factor, it's the same as before. We're just going to take this fraction, except I just need to simplify it. So the zeros just cancel, it's 1/6. Oops. But feel free to double check it in the calculator. All right, next example. We'll do my small, now it's not a triangle, but I'm going to draw it anyway. All right, so really, there's 3 numbers here. I don't need all 3 of those numbers. What I really need is whatever corresponds to these 2, which will be this one and this one. Now, if you're not sure which ones correspond, see, we're talking about PS. So PS would correspond, if you look up at the top here, PS would correspond to TW, which is this one right here. So you can kind of use the letters to help you decide which ones correspond with which ones. So I'm going to do 15 and 25. Those are the 2 lengths that I'm using from the small quadrilateral. And then x over 35.
Okay, I'm going to take that, I'll set up a portion, 15 over x equals 25 over 35. I'm going to multiply both sides times x, so that these go away, both sides by 35. Those go away, it's 25x. Again, if you cross multiply this, because that's how you learned, do your thing. I'm not going to teach it that way, but if you know how to do it, you do it. 5 times 5, divide by 25. 21.
Scale factor was that 25 over 35 here. All right, this one, similar. It's just got the 4x plus 6 instead of just a regular x. This is where all that math review, guys, starts showing up. So, yeah, let's do it. Same things.
Yeah, small one on top, so the small side is 24, big side is 32. And a big rectangle, the smaller side is 4x plus 6, and this one is 40. So we got 24 over 4x plus 6 equals 32 over 40. This way, multiply times 40, times 40, they go away. And then times this 4x plus 6, 4x plus 6, they go away. So 40 times 24, 960.
And then this is the kind of a tricky part, guys. We've got to do 32 times this. So you actually have to distribute the 32 times the 4.
Which is 128x, and the 32 times 6, which is 192.
And now it's just an equation. I need to solve it.
Let's see. Okay, my hand is falling asleep. 6. Oops, I didn't show my work. Oopsies.
Cats are waking, making weird noises. Okay, here's my scale factor, 32 out of 40. I already know it's going to simplify to 4/5, but feel free to type that in your calculator. All right, word problems. It's pretty much the same. We're just going to draw a picture, okay? So we've got Melody here. She's 5 feet tall. Boop, 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 boop. She's 5 feet. She casts an 84-inch shadow. Now these are in different units, and I'm paying attention to that, seeing if it's going to come back and pause. All right, I'm going to draw a picture because there's another guy. How tall is her friend? All right, here's her friend. He's tall. All right, how tall is her friend? So we don't know how tall he is. If his shadow is 1 foot longer, not just 1 foot, 1 foot longer, right? Now here's the tricky part. This measurement is in inches, and it's saying it's 1 foot longer. So either I have to convert this into feet, or I have to convert it, add 1 foot in inches. That to me seems easier. because I know that 1 foot is 12 inches. So I know that his shadow is going to be 12 inches longer. Do you have to do this for every word problem? No. Some word problems, they're all going to be in the same units and you'll be fine. You don't have to worry about converting it. What you have to make sure is that when you make a ratio, like this up here, like 32/40, when you make a ratio, that those two numbers are in the same unit. Okay. All right, so this one would be 96 inches. We've got to set up our ratio now. So set up our proportions. So we've got 5.
This one's the smaller one, so 5 and 8, 84. And then the larger one, we've got x and 96.
Or basically we're saying this is comparing to that, and this is comparing to that. So 5 is comparing to x, 84 is comparing to 96. And now we can do our little solving.
So x times x on both sides, times 96 on both sides. 96 times 5, oh gosh. 96 times 5. 40. Let's have it 84.
Oh, now this, it doesn't really make sense to me that this is in fractions, so I'm going to 5.7 feet. Now that does not mean he's 5 feet 7 inches, guys. That's one of the biggest misconceptions. But he's 5.7 feet. I'm not going to make you change it into feet and inches. That would just be mean. Not like that. Okay. Great. Well, I'm in office hours from 10:30 to noon, which you're probably watching this during that time anyway, or maybe after that. Feel free to ask questions, email me. Yeah. Have a good snow day.